chapter that we're in. Got our calculators out because we're probably going to need them. All right, here we go. Number 1 says, this unit that we're starting is called combinatorics. Combinatorics. How many ways can you arrange 5 books on a shelf? Well, first of all, anybody have a guess? 25. Good guess. Not the right answer, but a good guess. Anybody have another answer? 20. That's not even a good guess, but and not infinite either. All right, let's talk about it. We have our bookshelf. And pretend that it has 5 slots on it. Is that all of them? Yes, thank you. Hey, are you going to send me the list? I emailed you.
Oh, I just got back. I was hearing the answer.
Oh, good. Thank you.
Feel better about that?
Okay.
I was out.
Okay, we have. This is Whistler.
What?
We got class going on here.
Is that a Wordle?
No. I have 5 books. I'm going to put them on a shelf. So here they are. They're all laying right here on the table. I'm going to grab a book and put it in the first spot on the shelf. How many choices do I have to fill that first spot? 5. Now, that does not mean there's 5 books in that spot. It means I have 5 different choices. I could put book A, book B, book C, D, or E in that first spot. Okay, so I picked a book and I put it in the spot. Now, I have to put a book here. How many choices do I now have for that spot? 4. There are only 4. I picked a book and put it here. Now there are only 4 left, right? So now I pick one of those and put it here. Well, how many choices do I now have for this spot? 3, and then 2. And for the last spot, I don't have any choices because there's only 1 book left to put there. Right? Now, what do I do with these numbers? I multiply them together. The fundamental counting principle says that if you can pick one thing this many ways and another thing this many ways, the total ways you can pick is a multiplication. So 5 times 4 times 3 times 2 times 1. Now, could we type that in our calculator? Absolutely. Some of you have already done it. What do you get when you multiply all those together? 120 ways. So there are 120 ways that you can arrange 5 books on a shelf. Now, what if this had been arranging students in a row? If you had 5 students, how many ways could you arrange them in a row? Wouldn't it be the same thing? It doesn't matter whether it's books or people or, I don't know, fruit, whatever. If there's 5 of them, they can be arranged 5 times 4 times 2 times 2 times 1 ways. Now, think about this for a second. What if there were 20 of them? What if there were 20 books on the shelf? It'd be the same thing except what? It'd be 20 times 19 times, oh my goodness. Now, we can do that for sure, but that's going to be a little time consuming, right? Well, wait a minute, what if there were 100? That would take forever, right? 100 times 99 times 98. So luckily, there's a shortcut. When you start with a number and you multiply by each number going down by ones, so 5, 4, 3, 2, 1, or 10, 9, 8, 7, 6, like that, that is called factorial. So this number is 5 factorial. The symbol for factorial is the exclamation point. So 5 factorial means 5 times 4 times 3 times 2 times 1. So on your calculator, if you press the math button, the regular straight math button, one of the options across the top is probability. So if you scroll over to probability and look in your list, do you see the exclamation point? All right, so second quit, because to use it, you got to put the number in first. So press 5, and then math, and then over to probability, and down to exclamation point. And did it say 120? So it doesn't matter anymore how many people or books we have. Our calculator will do all the multiplication for us. Okay? All right, let's see about the next one. How many ways can 9 people stand in a line? Tishan?
Will we always be able to use a calculator?
Pretty much. And if you're not, I'll keep the number small. All right, 9 factorial. Oh, I gave the answer. Shoot, how many ways can 9 people be seated in a row? Or can stand in a line? It's 9 factorial. So 9 factorial is what? I don't have it memorized. 880. So how many ways can 9 people be arranged in a line? 9 factorial, just like books on a shelf. And that, when I type it into my calculator, is apparently that number right there. How many ways can prizes be awarded for first, second, and third place in a race with 10 contestants? Okay, now, stop. This isn't 10 factorial. How many people are getting prizes? Not all 10, only 3. So here are the 3 prizes. Here are my 10 people. One of those people is going to get first prize. How many choices do I have? I'm getting ready to pick a winner. How many choices do I have to give first prize to? 10. But now, I have to give away second prize. But there's only 9 left. And then third prize, now there's only 8 left. Again, you always multiply when you do this. When you do blank, 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 you multiply them. So how many ways can 3 prizes be awarded to 10 people? 720. Now I'm going to talk about, actually I'm not. That's it, 720, perfect, that was easy enough. All right, Mrs. Ford has 8 jumpers and 10 shirts. How many outfits do I have? Well, every morning I go to my closet, I gotta pick a jumper, and I gotta pick a shirt. Half the time I don't match, I'm not worried about it. I need a jumper and a shirt. I'm picking a jumper, I'm picking a shirt. How many choices do I have for jumpers? 8. How many choices do I have for a shirt? 10. When you do this, you always multiply. How many outfits are possible? 80. 80. In how many ways can the home row of the keyboard, and those are the letters, like when you type the main row there, how many ways can you arrange those letters? Well, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So what? 9 factorial. Exactly. Let me say it again. How many ways can you arrange 9 things in a row? I don't care if they're letters, books, or people, or anything. How many ways can you arrange 9 things in a row? 9 factorial. So we already did that one. 9 factorial is this number right here. So that's the answer to the question. That's how many ways those letters can be rearranged. How many ways can you answer 10 true-false questions? Okay, now stop and think about this for a minute. Here's your answer sheet. It has 10 blanks on it. Okay, there's the answer sheet. How many ways can you fill that out? Like, you're just random guessing, okay? So think about it now. I got an answer. I have to answer question number 1. How many different ways can I answer question number 1? 2. It's a true or false quiz. So aren't you going to say true or false? We're assuming you're going to answer it. So true or false. You have 2 choices. Now you move on to question number 2. Well, how many ways can you answer that one? 2. And won't all these be 2? And what did I tell you do to these? Do we add them or what? We multiply them. So the answer to that question is going to be 2, 2, 2, 2, 2, 2, 2, all times itself 10 times. Now that is not a factorial. What is that? 2 raised to the 10th power? You can always multiply 2 times 2 times, you know, you can do that. But this one would be 2 to the 10th, which is 1,024. So there's 1,024 possible ways you could fill out this answer sheet. All right, let's see if you can figure out 8 on your own. Can you get a start on 8? Here's the deal. You have 10 people, but you're only going to give out 4 prizes. So somebody's going to get first, somebody's going to get second, third, and fourth. So see if you can figure out what that is. Anybody have an answer? Tishon?
50-40.
Yes, 5,040. How did you do that, Tishon? It's exactly right. How'd you do it?
I just did, I know there's 4 spots, so I just went down from 10 till we got to 7.
Exactly. So he said, look, I got 10 kids in the room. I'm going to give away first prize, and second prize, and third prize, and fourth prize. So there are the prizes I'm giving away. I have 10 choices for first place. So Campbell got the first place ribbon. Okay, now she's out of it. So now there's only 9 kids left. And then 8 and then 7. Multiplied those together and got 5,040. How many got that? Wonderful. Wonderful. All right. Oh goodness, a whole page. Here we go. How many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits? Tishon?
You missed one on the first page.
Oh, I did? I'm sorry, which one did I miss?
Number 5.
Oh, I did the Mrs. Ford problem and forgot to do the Mr. Ford problem. All right. Mr. Ford has 5 sport coats, 12 shirts, and 10 pairs of pants. Assuming that everything matches, how many outfits does he have? So, he goes to his closet every morning and he has to pick a sports coat, a shirt, and a pair of pants. How many ways can he can he pick a sport coat? 5. How many ways can he pick a shirt? And pants? And then we'll multiply those numbers together. I got 600, did you? So he has 600 outfits possible. Sorry about that. All right. How many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits? So let's draw this license plate. And I don't mean literally, but we have 2 letters. It's going to be a letter and a letter, followed by 3 non-zero digits. Digits are numbers, like 1, 2, 3. So the license plate's going to be something like PQ587. And how many of those are possible? Well, how many letters are there? How many letters in our alphabet? 26 letters in the alphabet. If you're not sure of that, you probably should write that down, make a note of that. You need to know there's 26 letters in the alphabet. Okay? Now, how many letters are there for that second blank? Actually, 26. The problem doesn't tell me that I can't repeat. Have you ever seen a license plate that had 2 of the same letters in it?
Yeah.
Yeah. By the way, how about that license plate I sent you guys over break? Did anybody even open that email? And look at it?
Yeah, we did.
Wasn't that the cool? No one, only one person commented. That was.
We know we were like, yeah, I wasn't sure if it like goes out. Yeah. So like, if it was like.
It was an email, so you can
Yeah.
reply it just like for.
Well, it doesn't matter. I just thought that was the
Yeah,
coolest thing I ever saw. Okay. I want one, except I think you have to pay extra for those, and I don't pay extra, so I'm not gonna get it. But anyhow, 2 letters, you can repeat letters on a license plate, unless you're told not to, which we're not. Okay? Now, non-zero digits. There's 9 of them. 1 through 9 are the 9 digits, so there's 9. And then I could pick 9 and then 9, because I could have a 2 and a 2, or 5 and a 5 and a 3 or something, right? I'm going to multiply all those together, and that's going to be the answer. That's not a factorial, so you're going to have to multiply it. I got, for this question, I got 492,804. Different license plates with this structure are possible. Now, read the next question. We're going to make the same exact license plates, except you can't repeat anything. Well, that's going to change how it's set up. How's it going to change? What's it going to look like if you can't repeat anything?
26,
26, 25, 9, 8,
7.
perfect. That is absolutely right. Does everyone understand why the numbers changed here in the second round?
You can't repeat.
You can't repeat. So that means whatever letter you put here in the first blank, you cannot put here. So you have less options. All right, what's that one? Did you get that one typed in?
327,000.
Say it louder.
327,600.
Does that look okay to everybody? How many 4-letter call signs are possible if every letter is allowed? Okay, what they mean by that is, like, I watch Channel 13 because I love Chuck Lofton, WTHR. Those are that's the call sign, WTHR. You have a favorite radio station probably, and it's whatever, I don't know. Okay?
That'd be 26.
Well, I don't know. How many four-letter call signs are possible if every letter is possible? Now, it wouldn't be 26 factorial. It would be 26 times 26 times 26 times 26, wouldn't it?
Yeah.
Because you're allowing every possibility. So maybe your favorite radio station is WWWW. I don't think that's allowed in real life, but that's what this problem says. So that answer would be, I got 456,976.
Yeah.
Remember, we are multiplying these together. So 26 times 26 times 26 times 26. How many are possible? Go back to call letters. How many are possible if no letter may be repeated? So you still, it's a four-letter call sign, but no letter can be repeated. So what's that going to look like?
26, 25.
Yep, you guys are getting the hang of it. That's exactly right. And then we're going to multiply those together. I got 358,800. You okay with that? All right, 13. We're sticking with the call signs.
Is Y a vowel?
No, no. Y can act as a vowel once in a while, but traditionally A-E-I-O-U are A-E-I-O-U are the 5 vowels. There's 5 vowels. Okay? So how many call signs are possible if you can't use any vowels? Well, there's 26 letters altogether, but 5 of them are vowels. So now we got 21. Now, repetitions are allowed unless you're told they're not. So this one's going to be 21 times itself 4 times. 194, 481. And then finally, one more of these, number 14. Now we can have vowels and we can't have repetition. So if there's no vowels and there's no repetition, what's that gonna look like?
21, 20.
Yep. Times 20 times 19 times 18. Here are your 4 call letters. Then I got 143,640. You okay? Number 15. We have a baseball team that has 9 players and 9 starters. How many different batting orders are possible? No restrictions, just how many are possible from these 9 players? What's your thought on that? 9 factorial. Who said that? You're beautiful, Foster. Thank you. 9 factorial. When we say how many batting orders are possible, kids, aren't what we really saying is line them up in a row?
Yeah.
You go first, you go second, you go third. So how many ways can we line up 9 things in a row? 9 factorial. So we've had that number up here before. I can't remember what it is, but you know, because we did it. Now, Tank?
With the vowel one, why did we only do a 4 times with the vowels.
We only did any of them, there's a 4-letter call sign.
Oh, because it's attached to it.
Yes, yes, it's the same as number 11. Okay, and then 16 is the same, as we're back to the baseball thing. How many batting orders are possible if the pitcher bats last? Okay, now, what? Yes, very good. You want to teach us, class? You're doing great.
Thanks.
Here's the deal. You've got your 8 players. Here are my 8 players. Okay? Campbell's the pitcher. I said, Campbell, you're last. Go to the end of the line. Okay? Now, how many people are left? 8. So I gotta have a first person up. I have 8 choices, right? And then I have 7 and 6 and 5 and so on. So if you wrote that one out, which you don't need to, but if you did, here's Campbell, 1 choice on the end. There's the pitcher. But now, when I fill the first spot, there's only 8. And then 7, 6, 5, 4, 3, 2, 1. So it ends up looking like that. There's still 9 blanks, but there's no 9 because she got put on the end. So 8 factorial, you're multiplying by 1, so that doesn't matter. What's 8 factorial? 40,320. So the answer to problem 16 is 40,320. And then number 17. The pitcher bats last, and the best hitter bats third. Okay, so wait a second. Did you sign that? All right, so let's look at this. Here's my 9 blanks. This baseball team got 9 players. Now, pitcher bats last. So I have 1 choice for the last spot. That's the pitcher in that spot. And then the best hitter bats third. So I have 1 choice for that spot. Those people are designated in that spot. You don't get to pick somebody, they're there. All right, so here's the pitcher, here's the best hitter. How many people are left? 7. So now I have 7 choices to go first, and then 6, and then 5, 4, 3, 2, and 1. That amounts to 7 factorial. Got some extra 1s in it, but basically it's 7 factorial. And that makes sense if you think about it, because if you've already pulled out the pitcher and the best hitter, you only have 7 people left, right? And how many ways can you arrange 7 people? 7 factorial. So was that 50-40?
Yeah.
Yep.
Okay, yes, Kai? Is it an emergency? Leave your phone here. Leave all of your connections here. And hurry up. Because we're getting ready to do something extra cool. All right, this next problem introduces a new concept. So far, we've been drawing blanks and multiplying, and everything has been wonderful, and you're getting it, and you're all doing great. But this next problem, number 18, is a little bit different. It says I have 6 numbers. Oh, pretend they're on index cards or something. So you got an index card, it's got a 1, you got another one's got a 2. You have 6 cards with numbers on them. Okay? wanna know how many one-digit numbers could be made from those cards. So there's a one-digit number. That one-digit number could be a 1, or a 2, or a 3, right? How many different one-digit numbers are possible? Well, be careful. We're only using the digits 1, 2, 3, 4, 5, 6. So 6? Yeah, otherwise it would be 9, you're right. But I'm using only these numbers. So these are the one-digit numbers. But it says they don't have to be one digit. They could be two-digit. Well, now you've got 2 spots to fill. Wouldn't that be 36 of those? Think of all the two-digit numbers. Is 22 a two-digit number? Yeah, you can repeat it. It doesn't say you can't. Now, if you can't, that's a different thing, if it says that. But it doesn't say that. So there's 36 two-digit numbers. Or they could be 3-digit numbers. Well, how many of those are there? 216? So you've got 6 possible one-digit numbers, 36 two-digit numbers, and 216 three-digit numbers. The question says, how many do you have all together? So what will I do with those 3 numbers? What does all together mean? Add them. You add them up. That's exactly right. We're going to add them up. I'm going to tell you something here in a minute. This stuff can start to get confusing as we pile more things in. Did you get 258?
Yeah.
Whenever you have a situation where it's this, or this, or this, you're going to add. When the situation is an or, you're going to add them up. When it's an and, when I'm picking a number for this spot and a number for this spot, it's multiplying. Okay? So if the word connecting the 2 numbers is an and, you're going to multiply them. If the word connecting them is an or, you are going to add. 1-digit or 2-digit or 3-digit. Okay, is that it for that one? Yep. All right, number 19. Take the letters C-H-E-V-Y. How many are there? 5. How many words, and that's loosely, how many letter arrangements can we make?
Is it 5 factorial?
It's 5 factorial. One more time. How many ways can I arrange 5 things in a row? 5 factorial. And when you make a word, aren't you just arranging the letters in a line?
Yeah.
Yep, 5 factorial. How many 6-letter words can be formed from the letters Precal? 6 factorial, because there are 6 letters. 6 factorial. Now, I want to skip down to number 23, because it's basically the same question, but there's something a little different about it. What is different? Well, first of all, there's a lot more letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. Oh, but we have some repeating ones. Do you see that? Didn't have it before, but we have it now. There are 11 letters. So we're going to start with 11 factorial, period. But then we're going to divide. And we're going to divide by the repetitions. So there are 2 L's So I'm going to divide by 2 factorial. 2 L's, those are the L's. There are 2 U's, so I'm going to divide by another 2 factorial. There are 2 C's, so I'm going to divide by another 2 factorial. Are there anything else? There's the answer. So each letter that's repeated, you divide by however many of them there are, factorial. Now, listen to me, huge caution. When you type this in, you must have parentheses around your denominator. If there's more than one thing you're dividing by, then you gotta put it in parentheses. So, 11, math, prob, factorial, divided by parentheses, 2 factorial, 2 factorial, 2 factorial. I hope you get this number. It's a huge number. 4,989,600.
Yep.
Now I know I skipped a couple, but I'm going to do one more. Number 24. Now our word is Mississippi. So what do we do first? How many ways can we arrange these letters? What do we do first? Count them. Count them. How many are there? 3, 4, 5, 6, 7, 8, 9, 10, 11 again. So we start with 11 factorial. I don't care that some of them repeat. Okay, that I don't care. To start with, that doesn't matter. Count them up. Now, since there are some that repeat, it's going to be a division problem. What am I going to divide by?
4 factorial.
Well, I've got 4 S's, so I'll divide by 4 factorial. That takes care of the S's. I have 4 I's, so I'm going to divide by another 4 factorial. And 2 P's, so I'm going to throw in a 2 factorial. And since there's more than one thing in the bottom, parentheses. If there's more than one thing that you're dividing by, you've got to have parentheses. You just do. Wait, I got a lot less. I got 34,650. So you got that down? You know how to handle now words with repeating letters. How many ways can I arrange them? All right, let's go back and pick up the ones I left out. Number 21. How many social security numbers are possible if we let everything go? No restrictions at all. Anybody know what a social security number looks like?
3.
3 numbers, and then a dash, and 2 numbers, and then a dash, and 4 numbers. Now, if everything goes, if there are no restrictions at all, then how many? None at all. No restrictions. Any number you want to use can work. How many possibilities are there for this spot? 10. Why are there 10 for that spot? We got 0 through 9, right? Those are our digits. And if there's no restrictions, how many for this spot? 10. And then and what will I do with all those 10s? Multiply them. So how many are there? 1, 2, 3, 9. So 10 to the 9. Oh my, what is that?
There's 9 zeros.
Let's see. This would be a million, a trillion? There's a trillion of them? But what's the problem? Oh, is it a billion? Yeah, it's a billion. Because this would be a million, this is a billion, thanks. Yeah, there's a billion of them. But of course, are there really that many? I don't know. Do they allow a social security number like 0, 0, 0, 0, 0, 0, 0, 0? I don't know. They do or not. But if you allow every single possibility, there's a billion of them. A lot. How many telephone numbers are possible in the 317 area code? All right, so you got 317, that's your area code. Right now, how many phone numbers are possible? What's a phone number look like? 3, and then 4. And again, I don't think in reality you allow everything, but there are no, I didn't put any restrictions in, so if everything goes, wouldn't it be 10, 10? Wouldn't this be it?
Yeah.
Which is 10 to the 7th, which I think is 10 million. Now, in reality, we know that they don't start with 0, and I don't know what other rules there are, but there's 10 million. I want you to think about real life for a minute. Back in the day when I was growing up, okay, I'm one of 6 children, so we had 8 people in our household. And you know how many phone numbers we had? 1. Because all you had was a house phone, right? Well, now, those 8 people all have their own phones. So now your household, let's say you have 6, there's 8 people in your household. Now there's not 1 phone number, there's 8 just in your house. At least 8 just in your house. They ran out of phone numbers in Indiana. In the 317 area code, they ran out of phone numbers. It's easy to see why. So what did they do? They created a new area code. So some people that used to be 317 are now something different. It happened up north too. 219 became 260. Some of them split off because they ran out of phone numbers. Because everybody's got phones, right? Can you see how that happens? Absolutely. All right. We did number 23. All right, number 25. Interesting question. Explain why at least 2 students must have the same first and last initial at Cathedral. So I'm not saying that everybody has a match. I'm saying somebody's got a match. How do I know that? With absolute certainty, how do I know that there are matches out there? Well, think about it for a second. Here's your first and last initial. Assuming that your first name can start with any letter, there's 26 options. And assuming that your second name, your last name, can start with anything, there's 26 options there. So how many first and last name, first and last initial options are there? 676. Kids, there's only 676 options. How many kids are at Cathedral? More than that, right? And if there's only 676 options, somebody matches. So I'm not saying necessarily that there's another LF. I'm sure there is. But, well, Mrs. Finn. But there are definitely people out there who match because we only have this many options. Now, 26 and 27. This is the last thing I'm going to do today. We've done a lot of problems. So I'm going to read 26 and 27. I want you to read problem 26, A and B. And I want you to tell me if they are the same problem with different words, or are they actually two different problems? Both of them involve 20 people, and we're choosing two. Both of them involve 20 people choosing two. Are the problems the same?
Yeah.
Or are they different? I have a vote for the same right here. Everybody thinks they're the same?
Are they different?
Well, if they're different, tell me why they're different.
Well, because wouldn't the first one be 20 times 19 and the second one be 20 factorial?
No, they are different, but not that. The first one is 20 times 19,
Yeah.
but the second one is not. Here's the difference in the problem. I want you to think about it for a second. Okay, let's say there's 20 of you, all right? And I am going to pick a president and a vice president. So I pick him to be president and her to be vice president. Okay, I can do that. But could I also pick her to be president and him to be vice president?
Yeah.
And that would be different, right? That's a different leadership team. Same two people, but different roles. So in problem A, the order that I pick them matters. In problem B, if I say, okay, I need two of you to be in charge. If I pick you first and you second, or you first and you second, doesn't matter. No, not if I'm picking like a committee, because on a committee, you just want to be part of the group. It doesn't matter whether you're first pick or second pick. Think of Miss America. You ever watch Miss America pageant or one of those, Miss USA or whatever it is? Anybody ever watch that?
Josh does.
Josh watches them?
Yeah.
Okay. So at some point, they start picking the 10 finalists. Okay? When they pick the 10 finalists, do you care if you get picked first or second or third or fourth? No, you just want to get picked. You want to be in that final round. Now, at the end of the pageant, when they pick a winner, then it matters. If you are picking a committee, order doesn't matter. A leadership council, order doesn't matter. If you are picking for specific roles or specific prizes, then order matters. The difference in those two problems, order versus no order, is important. If order matters, it's what we call a Perm Mutation. And the notation we would use in this problem is 20P2, or sometimes it's written like this. That means, when I see this, I know I've got 20 objects, people, whatever. I'm picking two of them, and the order I pick them matters. If order doesn't matter, it's called a combination. You just want a combination of those people. Any combination. and that's 20C2 or C22. All right. Now, how do I evaluate these? Take out your trusty calculator you're about to learn. If you go to the Math Prob menu where you were to get your exclamation point, do you notice an NPR and an NCR? That's your button, or those are your buttons, okay? So second quit. First of all, put in the 20, the big number, so put in 20. Math, prob. This is the P problem. We're doing the P problem first. So NPR, 2, enter. And there's your answer, 380. So the answer to this one is 380. Using my P button, what I call my P button, my permutation button. And then this one will be 20, math, prob, and CR, 2, and it's 190.
Is that the view?
Huh?
Is the C for view, like the 20C?
Yes, that's problem B. No order matters. Okay, we have one more to do, guys. So I want you to read number 27. And the first thing I want you to do is figure out which one's the P and which one's the C. Don't say it. Let's give everybody a chance to read them. Remember, if you're picking for specific jobs, then order matters. If you're picking a committee, then order doesn't matter. So problem A, 13P4 or 13C4? C4. A is a C problem because you are picking a group. You're not designating specific jobs. But in A, or in B, problem B, you are choosing specific roles for the people. So that one is a 13P4. I know this is day one, but do you sort of see the difference between the two problems? All right, let's type them in, get the answers. Does everybody understand why it's 13 and 4 this time? Does that look okay? All right, you guys have been real troopers.